two definitions for you today: interrupting rating and short circuit current rating, because you really almost can't talk about one without talking about the other. So interrupting rating first, that's the highest amount of current at a device's rated voltage. The device is rated to interrupt under test conditions. Okay, so interrupting ratings is that's a property that overcurrent devices have. So fuses and breakers, those are designed to interrupt current, right? That's what they do. So how much current can they safely interrupt under specified test conditions without experiencing a significant amount of damage? That's what we have. That's what we call the interrupting rating. So if you go to the parts store, whether you go to Lowe's or Home Depot or whether you go to an actual supply house, and you just ask for a single pole 20 amp breaker, and you grab it, stick it in, that thing is going to have an interrupting rating. Almost without exception, the interrupting rating is going to be 10,000 amps. That means that circuit breaker can safely interrupt 10,000 amps worth of fault current without experiencing significant damage to itself. Now take a look at this circuit breaker. This has an interrupting rating of 42,000 amps, and again that's at 120/240 because it's the highest current at the specified voltage that the device can safely interrupt. So this is rated 42,000 amps. I just mentioned that most circuit breakers that you buy are going to be rated 10,000 amps. Now when I say most circuit breakers, I'm talking about most, molded case circuit breakers that you're installing in a commercial building or in a house. I'm not talking about big, power circuit breakers that get racked in and everything else. Just your regular run-of-the-mill circuit breakers. Usually are rated for 10,000 amps unless you tell the supplier that you need something different. Well, when would you need something different? You would need something different when the available fault current is greater than 10,000 amps. What happens if I put 20,000 amps on a circuit breaker that's only rated for 10,000 amps? Well, I'm not exaggerating. That circuit breaker explodes. I mean, sometimes in the industry we say the term blow up, right? Oh, it blew up. We say the term blew up when we have arcs or sparks or anything interesting. I mean it when I say that circuit breaker will blow up. It will explode, okay? So it's imperative that we understand what an interrupting rating is and that we install equipment within its limitations, within its ratings, especially its interrupting rating. So we need to know the available fault current. And then we need to install a properly selected overcurrent device with an interrupting rating that can handle the available fault current. Now, that's a rule that you would find in 110.9. Overcurrent devices must have an interrupting rating that's equal to the available fault current that's at least equal to the available fault current at the line terminals of the equipment. Here we've got a fuse at 250 volts AC. This thing has an interrupting rating of 200,000 amps. At 250 volts DC, its interrupting rating is 100,000 amps. So we can install that in a lot of locations. Having available fault current higher than 100 or even 200,000 amps is pretty unique. So there you go. Equipment has to be installed within its ratings. We know what an interrupting rating is. That takes care of the overcurrent devices, the devices that are intended to interrupt current. Well, what about the enclosure itself, right? Like the panel board. I mean, the panel board doesn't interrupt the current. The circuit breakers inside of it do. Well, what's the point of having a panel board that's full of 42,000 amp rated breakers if the panel itself is only rated for 10,000 amps? Well, that's where we get the short circuit current rating. So the short circuit current rating is the rating that other pieces of equipment have, not circuit breakers and fuses. Circuit breakers and fuses have interrupting ratings. Other items have short circuit current ratings, and that is the amount of current that a piece of equipment can be connected to without sustaining damage under test conditions during a fault. So it's very similar to the interrupting rating. So let's take a look at the label on this panel board. It says the short circuit current rating of this panel board is 200,000 amps symmetrical at 240 volts. Cool. Put that wherever you want, right? I mean, it's pretty rare that you're going to have an installation with more than 200,000 amps of available fault current. But let's not stop reading. Or 22,000 amp symmetrical if it's equipped with main lugs, feed-through lugs with no protective device. Or it's whatever the lowest rated device is installed in the panel board, whichever is lowest. Okay, so buying this thing off the shelf, it's rated 200,000 amps. But that's assuming that there's a breaker or fuse that's protecting it. If this thing is wired in main lug with no upstream overcurrent device, it's not rated 200. It's only rated 22,000. And if I have a bunch of 22,000 amp rated breakers inside of it and one 10,000 amp breaker inside of it, guess what? Short circuit current rating of that panel is only 10,000 amps. So we need to know the available fault current for every point of every installation where we're installing overcurrent devices or equipment. Usually you can get higher short circuit current ratings than interrupting ratings. Usually, on things like panel boards. But there's other pieces of equipment that have more intricate components where getting a high short circuit current rating might be very difficult. Air conditioning equipment, like a rooftop air conditioner. A lot of times the short circuit current rating for those pieces of equipment is only 5,000 amps. So you might have to employ like a series rated system or do something, use current limiting overcurrent devices, use some ingenuity to figure out how to protect those units. So that's the definition. What's the rule? Well, 110.10, short circuit current ratings, circuit impedance, and other characteristics says listed equipment installed in compliance with its instructions and ratings is considered compliant, just like 110.9. 110.10 tells us that equipment has to have a short circuit current rating that's equal to or greater than the available fault current, and we follow the instructions to ensure compliance. But we do need to make sure that we're reading all of those instructions. So here's this piece of equipment that has a short circuit current rating of 50,000 amps. Now, that's a fair amount of current. I mean, if you've ever seen 50,000 amps introduced to a couple of wires, it's a lot of movement from that magnetic force. So in a piece of equipment that has a short circuit current rating like 50,000 amps or higher, a lot of times you'll find instructions for conductor lashing or bracing, and that's what we have circled down here where it says wrap all your line cables together and all your load cables together with nylon rope 3/8 of an inch in diameter or with a tensile strength of 2,000 pounds. Wrap it at 6 inches and then 12 inches with 5 wraps and additional 6 wraps and everything else. So something kind of like this. So do I have to brace my conductors and lash my conductors like this? Yes, if the instructions of the equipment tell me. Why would the instructions of the equipment tell me? Well, because that's part of how the equipment gets its short circuit current rating. I'm going to end this by showing you a quick little video from our friends at Eaton showing the effects of a short circuit on some conductors. Take a look. I think you'll enjoy it. Okay, so what we're looking at here in the video is 90 feet of 2-aught conductor, 480 volts, and we're going to apply 26,000 amps of fault current through them. So we just took a 90-foot length of wire and short-circuited it to a circuit breaker. We're going to turn it on from a remote location and see what 26,000 amps does to those wires. And after you get done watching it, I want you to consider why it's so important that we have to lash or brace the conductors inside of equipment where we have really high amounts of available fault current. Take a look at the video. I told you you'd like it. Be sure to like, follow, subscribe, and ring the bell.